This topic is about linked list. Before going to linked list, so this topic is about linked list. Before going to linked list, let us check the basic things about array. So what in an array? Array is a linear data structure that stores the elements in contiguous memory location. What it means? Suppose we are having 5 elements 10, 20, 30, 40 and 50. And these 5 elements we want to store in a array. How to store? Suppose let us take a array A. So we need to specify the size first. So as we are having 5 elements, let us take as the maximum size 5, and then it can be stored like this. Within second bracket we can specify in case of code. But in graphical representation, what it should be? So in graphical representation, there should be 5 blocks, and each block should contain one data. Okay, so first 10 should be stored, then 20, then 30, then 40, then 50. Now if we want to access these 5 elements, how to access? Using index. And as you know, array index always start from 0. So 10 should be stored at the element or at the index 0, then 20 should be at the index 1, then 30 should be at index 2, 40 should be at index 3, and 50 should be at index 4. Now we are having 5 elements and the index is, the maximum index is 4. What about n? If we are having n data, so the maximum number of index should be n minus 1. How n minus 1 is coming? 5 minus 1. So how 4 is coming? Using 5 minus 1. So n minus 1 is coming by deriving 1 minus the number of elements. Now there are certain disadvantages for array. So the disadvantages are, as you are storing all the elements should be stored at contiguous memory location. If the first element is storing at 0th index, that means the second element should be stored at 1th index. The third element should be stored in second index. The fourth element should be stored in third index, like this. Similar way, another disadvantage is, before declaring any array, we need to specify the maximum size, and that is fixed. We cannot change it. So if we want to store, suppose we want to store letter after, we want to store 60. Where to store? Because this array can only have 5 elements. How to store 60 then? We cannot store 60. That is the prime disadvantage of array. So to make efficient use, we can take another linear data structure that is called linked list. And linked list is a data structure that is free from the mentioned disadvantage of array. Unlike an array, linked list does not allow random access of data. You can only access the data sequentially, but if you do not want to specify the number of elements you need in prior of declaring it, it is possible for linked list. So what is a linked list? So for a basic terminologies, let us check. Linked list can be a linear collection of data elements, and the data in a linked list are stored inside the nodes. So linked list is a data structure that is done using nodes, or that is represented using node, and the nodes are contain data. Now in case of linked list, a node contains 2 parts. Every node in a linked list contains 2 parts. The first part is called data part, where we store the data. The second part is called the address part. What we store in this address part? This address part stores the address of the next element. Suppose 1, it is the first element, 2 is the second element, so the address part of 1 should contain the address of 2. Similarly, the address part of 2 should contain the address of 3. Similarly, 3 will contain the address part of 4, like this. What about the last one? Okay, here 7 is the last node, or this node is the last node that is having, or that is containing data 7, and this is LUT. How to specify this is LUT? Graphically, we can give one cross. But in case of program, we can specify using null here. That is how we can represent. But another question may arise, from where we can get the address of first one? From where we can get the address of one? There is one start pointer that stores the address of the first node of a linked list. So the address from start, we can get the address of first node, and then we can traverse all the other node to the last one. So in a linked list, two part is there. First part, here in case of this is the integer part, and second one, add it is having the address of the second node or the address of the next node. So this part should be a pointer, this part should be a pointer part, right? Now let us check how this data structure or the linked list data structure should look like. So for specifying in case of code, we need to first create one structure. So we are creating one structure for node. It is having two parts. First one is data part. Okay, here int is given, but as per your requirement, you can give any kind of data type you want. And the second part should be the pointer part that will have the address of the next node. Now the question arises, what if we do not have any node in a linked list? If we are having a empty linked list, then the start should contain null value. If any node is not present in a linked list, then the start must be null. Okay. Now let us check what are the difference between array and linked list. In case of array, we need to specify the maximum number of element before declaring it. But in case of linked list, we do not have to worry about that. We can implement it, and then as per our requirement, we can increase our number of nodes. That is the major advantage of linked list over array, right? Now let us check linked list. Okay, there are several kind of linked list is there, type of linked list is four. The first one is singly linked list. What do you mean by singly linked list? Singly linked list is the most simplest kind of linked list. Here every node can contain only two parts. The first part is called data part. First one is called data part, that contains the data we want to store, and the second part is called address part. What is stored in the address part? Address part store the address of the next pointer or the next node. So this is the pointer part, and the first one is data part, and the data type can be specified by the user. Now how singly linked list should look like? This is the example of singly linked list, where we can start from a start node that contains the address of the first node, and then we can traverse or we can visit every other node to get the data. Now the question is, what are the operation we can perform over a linked list or over a singly linked list? The first thing we can perform, is called traversing. What do you mean by traversing? Traversing means we are accessing each node in order to perform some processing. It can be displaying the data, it can be counting the number of nodes, it can be anything, but we can traverse every node of a singly linked list in order to perform some data. Now what should be the algorithm, or how it should look like? Okay, I have told we have to start from, or we have to begin from start node only. So as we are traversing and as we are visiting every other node, so what we can do? We can have a pointer here. And that pointer should be incremented after traversing every node. So we can set a pointer PTR, at the start node, right? Initially we can start a PTR. Now we have to traverse, but up to somehow or at somewhere we have to stop. Where we have to stop? See, every node is containing one address of the next node, but the last node is not containing any, it is containing null value. So as we are traversing, until which one we should go? Until PTR next becomes null, we have to traverse that, right? Whenever ptr next become null, then only we can stop. Now let us check the algorithm for it. If we want to traverse, so we have to set one pointer ptr at the start node, and we need to traverse until ptr is not equal to null. When until ptr is not equal to null, we need to traverse, and we can apply some processes over the data part. What is the data part? Ptr data means the data part given here. So the data part for the first node is 1, data part for the second node is 2, data part for the third node is 3. So we can apply some processes on this data part, and after doing the process, what we can do, we can move to the next part, that is the address part. So how this algorithm should look like? Okay, we have the first node. Okay, initially we have data 1, and after accessing the data, we are going to the next part. So what is next? Ptr equal to ptr next. That means initially ptr was a start. After getting the address of first node, now we can move ptr to first node. After accessing the data, now ptr is moving to the next part. Now ptr is said as ptr dot next. What is ptr dot next? If it is ptr, then ptr next means this one. That means now we need to move ptr to the second node, and it will again go back to step 2, as we are having one loop here. Next, again it is having some data. Okay, it will access some data. Okay, data 2 is accessed. Now it is again coming back to this line, ptr equal to ptr next. Okay, ptr next is having some data, so we need to move ptr here, right? Again, after accessing the data, it will move ptr to here, then here, then here. Okay, whenever ptr is there, now ptr after accessing data 6, ptr will move to ptr next, that is 7. Okay, ptr is now here, ptr is here. Now we are accessing some data. Okay, now 7 is accessed. What is the next step? We need to go to ptr next, but ptr next is null. Here. So what we have to do? So our algorithm says we will only traverse until ptr not equal to null. Here, after accessing ptr next equal to null, okay, if we just go, now ptr become null here. At 7, if we just traverse ptr by 1, it becomes null here. So we must stop, right? So here we must end the loop, and we should exit from here. That is the algorithm for traversing any linked list. Now let us check another algorithm for traversing. Suppose we want to count, or we want to print the number of nodes possible in a linked list. How to do that? How to count? Okay. So if we want to count, that means we need a counter. We must need a counter that will be incremented from 0 to the number of node. Initially it will be 0, as we are coming from the first node. Okay, let me take here an example. Okay, suppose one start node is here, that is having the address of one node, then it is having another node, then it is having another node. Okay, initially we are having 3 nodes that are having the data 1, 2 and 3, and this is the end. Now we want to check, or we want to count the number of nodes. Initially count is 0. Okay, count is 0 here. So let me draw here c equal to 0. Now one pointer should be there at ptr. Let me take one another color. So ptr should be initially at start. Now as we need to count, so we are at start node, we are having data of 1, so ptr should be traversed to 1. So ptr is 1. As ptr becomes 1, count should be incremented by 1. So initially count was 0, so it will be now plus 1, that is 1. Counter is 1. Now we need to move ptr equal to ptr dot next. Is ptr next null, or is ptr null? Is ptr will become null if we go to ptr next? No, ptr will not become null, as it is having some another node. So ptr next means we are updating the ptr by 1. Now ptr is at 2. So as ptr is at 2, so we need to update our counter. So initially it was 1, now it will be again updated to 2. Yes or no? Okay. Next again it will come to ptr dot next. Yes, ptr next is there. Yes, one data is there. So ptr next is having some node. So we must increment the ptr by 1. As ptr incremented, so the counter should be also incremented by 1. So now counter becomes 3, right? Again go to ptr next. Okay, if we go to ptr next, ptr will come somewhere but it is null. ptr will come to somewhere using ptr next, but it becomes null. So whenever ptr become null, we should get out of the loop. And if we get out of the loop, then what is the next step? Next step is we need to write the count. What is the current number of count? Current number of count is 3 only, and we are having 3 nodes. Yes, our algorithm comes right, and thus we can count the number of node present in a linked list. Okay, that is possible. Is there another operation we can do? Yes, so apart from traversing, we can also search for a value in a linked list. How? So as we have already discussed, linked list is having two parts. One is called information part or data part, and the other one is called next part. Using next part, we can access the next element or next node. Now, what searching means? Searching means we are searching for a value, or we are checking if it is present in the data structure or not. So suppose we are having one data structure. So suppose we are searching for any value. That means we are checking if it is present inside it or not. So how to check? We need to compare with the value. Suppose we want to search for, suppose any data. Suppose we want to search for value 4, right? We want to search for value 4. So if we want to search for value 4, what we have to check? We need to check whether the value present in this node that is equal to 4 or not. First of all, graphically check it. So we are searching for 4, and as we have compared between 1 and 4, it is 1. Okay, these are not equal, right? These are not equal. That means now we have to go to the next node. Now check whether 7 is equal to 4. Okay, no, 7 is not equal to 4. That means we need to again update it. As we have to update it. Okay, now let us check if 3 is equal to 4. No, it is not equal to 4. Then only we have to again go to the fourth one. Okay, now we are having data 4 and it is equal to 4. Now our search become complete at this node. Our search become complete after 4 iteration. Now let us check how the algorithm should look like. Okay, initially we have to start from or we need to begin from start. Okay, so as 1 is the first node, how we can get the address of 1? We can get the address of 1 from start node only. Okay, that is why ptr equal to start. Now what we have to do? We need to traverse through the linked list, but at the same time what we have to do, we need to check the value we want to searching for, if that is equal to pointer data, or ptr data means if it is equal to the data present in this node or not. That means after getting the address of 1, ptr will be at 1. Now what is the next step? Next step is the value we want to searching for. We have searched for 4, the value 4 that is equal to ptr data, that is 1 or not? No, this is not equal to the data. So as it is not equal to data, we need to come to else part. So there will be two things. One is if or else. What is if means? If the data is equal to, then we will go for this if part. If it is not equal to, then we will directly go for else part. And it is for else part. So that means 4 is not equal to 1. That means we need to go for ptr equal to ptr next. Then as it is ptr next means now ptr comes to 7. Now if 7 is equal to 4, no, 7 is not equal to 4. That means again it will come to else part only. Then also it is 3. That means it will again come to else part, and now it is 4. Okay, so now the value we want to searching for, that is equal to ptr data. Then as it is equal to, then what is the next part? Next thing is we need to set the position of ptr. We need to take the position of ptr, and then we need to print it. We can print it or whatever we want to do. That means after getting the position of that data, what we can do? We can print that position also, right? So that is we can do. Now what else we can do? We can insert the data. What do you mean by insert? At inserting, we can insert a node. We want to insert a node. How we can insert a node? We can insert a node at the beginning of a linked list. Yes, it is also possible. Suppose we want to insert a node at the beginning, at before 1. That is also we can do. How we can do? I will explain you. I will explain you. What is the next case? Next case is we can insert any data or we can insert any value after here. Yes, we can also insert a node after 5 also. Or we can insert a node in between any value, that means after 3 also we can insert any node, or before 4 or before 2 we can insert any node. That means 4 cases are there if we want to insert any new node at a linked list. What are the cases? Either we can insert at the beginning of a linked list, either we can insert at the end of a linked list, or either we can insert after any given node, or either we can insert at the or either we can insert before any given node. So these are the 4 cases for insertion a node in a linked list that we will discuss in the next video.